Hello students, today we are going to discuss the important topic in complex, that is IUPAC nomenclature. How can we read the nomenclature of a complex compound? Already we know, you have already read. It may be a complex compound, may be organic compound. It has generally two names. One is common name, another is IUPAC name. IUPAC name, it has a systematic nomenclature. That means it follow the specific rules. So today we are going to discuss that the IUPAC nomenclature of complex compound. Before giving examples of nomenclature of organic, that is complex compounds, let us know what are the rules used in the IUPAC nomenclature of complex. Let me discuss one by one. First rule is that if it is a ionic complex means it has both cation and anion. Then in the nomenclature, first it will start from cation name, then it will be ended in anion name. For example, sodium, for a binary compound, suppose sodium chloride, we cannot write chloride and sodium. We are starting the name from cation name, then anion name. So first cation nomenclature, then anion nomenclature. Okay? Then second rule is ligands are named in alphabetical order. That means so many different types of ligands are written inside the coordination entity, in the coordination sphere. Their name will be given in alphabetical order. Just like in organic we have read, the substituent will be named alphabetical order. Similarly, here the ligand's name will be written in alphabetical order. First A, B, like this. Name of the anion ligand ended in O. That means for any anion ligand, like suppose that is Cl minus or Cl minus, OH minus, like this, it will be written the suffix O, means ended O. For example, Cn, cyano. Cn, if you write Cn minus, the name will be cyano, like this. For example, sulfate, name as sulfato, like this. So for all negative ligand, it will be ended O. O will be added as a suffix. So cyano, sulfato, nitro, hydroxo, like this can be used. Then, but if the ligands are neutral ligands, then their direct name will be used without changing the name, but some exceptions are. For example, water is there, it is not water. It is used as aqua. You have to remember as a ligand name is aqua. And for ammonia, ligand name is amine, we have to remember. For CO, it is carbonyl, and for NO, nitrosyl. For NO, it will be nitrosyl, for CO, carbonyl, and NH3, amine, water, aqua, like this, some specific name will be used in the nomenclature. Then if the ligands, more than one ligands are used, then we will use di, tri, and like this. If the more than one ligands are used, then for if more than one is used, then we can use the term bis tris tetracis can be used. For example, if En is En whole 2, we can use bis ethylene diamine. we can use bis. Bis means 2. Bis ethylene diamine. Ethylene diamine. We can use short form. So En whole bracket 2 means bis. 3 means tris. We can use this. Then in the complex, metal atom has two types of valency. One is primary valency, another is secondary valency. The primary valency satisfies the oxidation number. So oxidation number of metal atom is indicated by Roman number. Roman number in parenthesis. Like this: 0, 1, 2, 3, like this can be used in Roman number. That is indicate the oxidation number of metal atom in the complex. Then for cationic or neutral complex, or if the complex is a cationic complex or neutral complex, then metal atom name will be same as element name. Suppose cobalt, it will be cobalt. Iron, it will be iron. Nickel, it will be nickel, like this. There will be no change in the name. When if it is a cationic complex or neutral complex. But if the complex is a negative complex, that is anionic complex, then the metal name follow the Latin nomenclature. That is Latin name. Latin name means we can use at the suffix as ate. Ate suffix will be used. For example, if it is a negative complex containing nickel, then name will be nickelate. Nickelate. If it is a cobalt, then cobaltate. Like this. If it is iron, it will be ferrate. Like this. So this indicates if the complex is a negative complex, then the metal atom name will follow the suffix ate. Nickelate, cobaltate, ferrate, like this. Because iron, the Latin name is ferrum, so it is ferrate. But cobalt, it has no Latin name, same, so cobaltate, nickelate, like this, it is follow. So you have to follow this if the complex is anionic complex. If the complex is a bridging complex, if the ligand is a bridging ligand means if the ligand connected to two metal atom, if the ligand connected to two metal atom, that is called bridging ligand. If the bridging ligand is there, then we fix before the nomenclature, mu symbol would you use, mu. Mu indicate it is a bridging ligand. This is identification of bridging ligand. You can use. Then some short form was used. OX indicate oxalato. En indicate ethylene diamine. Di-en indicate diethylene triamine. Similarly, tri-en indicate triethylene tetramine. Like this, triethylene tetramine. And DMG dimethyl glycine. PY means pyridine, NO means nitrosium, NO2 plus means nitronium. That means indicate these are the some positive ligand. Ligand generally may be negative or neutral, but some ligands may be positive. So NO means NO, if simply NO, that is nitrosyl will be used. If NO in plus form, that is nitrosium. If NO2 plus, that is nitronium will be used. If it is an ambidextrous ligand, if the ligand is an ambidextrous ligand, it depends upon the linkage of the particular atom to the metal atom, then name will be changed. If N is attached to metal atom in NO2, that is N-nitrito. If O is attached to metal atom, that is called O-nitrito. So it distinguishes the coordination of the particular metal atom to the particular atom with the metal ion, whether N is attached or O is attached. So there is a distinction between that in the nomenclature of NO2, because this NO2 is a ambidextrous ligand having two donor sides. So now let us discuss what are some examples of by taking some examples how can give the nomenclature. For example, if the complex is A4 FeCN6. This complex. So this complex indicates a ionic complex having cation and anion. This side is cation, this side is anion. So complex ion is negative side and metal is here positive side. So we can start, already I have told you, we can start the name first cation then anion. So nomenclature will be potassium, then we start the main complex. Is this part is the main complex. We start from ligand name. We start from ligand. Then ligand is your cyanide, that is cyano, or here 6 hexacyano. Already I have told you cyanide is a negative ligand ended with O, already written ended with O, that's a cyano. Everything follow the rules. So potassium, hexacyano, R is a negative complex means anionic complex, N will be 80. So iron Latin name is ferrum, so it is a ferret. What is the complex oxidation number? The oxidation number of metal atom is here 4 and -6, that is 2. So ferret 2. Parenthesis will be used. Parenthesis means bracket. The Roman number will be written in parenthesis using bracket. So the complex is potassium, hexacyano, ferret 2. This is the IPC nomenclature of this complex. Let the complex is like this. If it is Fe H2O whole 6 carrying 3 plus, this type of complex. Here there is only ligands are water. So as there is no cation here, we can start from the complex side. So ligand complex, when you start the complex, you start from ligand name. That is very important. When you give the nomenclature of complex side, complex ion, or complex cation, then you start from the name from ligand. So hexa, then aqua, (6) water is aqua, already written, water is called aqua. So hexa, as it is a positive complex, the name of metal atom will be same as element name. So iron charge is, as it is 0 and 3 plus, charge is 3, complex is 3. So iron 3, ion. So this is the hexacyano, hexa aqua, iron 3 ion. Suppose if the complex is both cation and anion is there, for example, chromium NS3O6 with chromium CN6, this complex. It is also one type of complex. Its name will be, as you see, as it is a negative ligand means whole complex is here 3 minus complex. As here 0, chromium is plus 3. So it is, we can say it is plus 3. So if you write, you can change the metal atom, cobalt, let it be cobalt. Chromium, this is cobalt. So we can write in this way, what? We can start from cation, we will start from cation, but it is, so hexaamine, here chromium charge is 3, here cobalt charge is 3. So hexaamine, as it is a positive complex, positive complex, metal atom name will be as element name. So hexaamine chromium chromium, then 3. Hexamine, chromium 3. Then you start the come to negative side. As a negative complex, hexamine, chromium 3, hexacyano, again repeat, hexacyano. Now as it is a negative side, negative complex, so we can write ATE, we will use ATE here. Already we have discussed here, ATE will be used as this side. AT will be used. So hexamine, chromium 3, hexacyano, cobaltate. Name will be cobaltate. Cobaltate charge is 3. This. So don't forget to write the Roman number, that is the oxidation number of metal atom in the parenthesis. If you don't mention this one, then you will get 0 mark. That is very important in the IUPAC nomenclature. You have to follow all rules. So this is the one complex, coordination complex. Both cation, anion, it is a cationic complex, anionic complex. So it is a ionic complex having cation and anion, both are in complex form. Then another you can use like this. Suppose CO En whole 3 whole 2, CO En whole 2, then here NH2, here OH, then attached to CO En whole 2. This complex, this type of complex indicate what? It is a bridging complex. This part is a bridging side, this part is a bridging side. What is a bridging ligand? Ligands connected to two metal atoms. So NH2 connect to CO and CO. That is a bridging. Bridging means we have to use mu symbol. So what is the name? You can start here. First, as it is ethylene diamine, we can use bis. Ethylene diamine. Ethylene diamine, bis ethylene diamine, you can use the bracket, then cobalt, but the charge of cobalt here, you will see the cobalt charge is +3, here cobalt charge is +3, because why? That is very important to calculate the charge, because this is a, if you see, here, this it carry OH minus and this carry also NH2 minus. So cobalt both carry here, both satisfying 3 valency. So bis ethylene diamine cobalt 3, then this is mu. Mu is used for this compound, this is called amido. NH2 minus, that is amido. Mu amido, then again mu what? Hydroxo. Mu amido, mu means bridging ligand. Mu hydroxo, then cobalt 3. Then, sorry, before that you are right, mu amido, mu hydroxo, then bis ethylene diamine, then cobalt 3. So you have to write in this way that you are bridging, if bridging ligands are there, then you have to use mu symbol. Okay? Then what are the other examples? What is the name? Same way, as it is a neutral complex having no charge, so element name, metal name will be the name of element. So we'll start from the ligand name in alphabetical order. So first B, bromido, bromido, because already we discussed that O will be used in the ligand name. So bromido, then dichlorido, then before that amine is here. You can add that amine, also tetraamine. First tetraamine, then bromido, then dichlorido, then cobalt, simply cobalt. Charge is 2 and 1, 3. So 3. So like this you can give nomenclature. Okay. I am giving one examples. You solve it and give the answer. So complex is like this: FeCN whole 4 whole bracket 2 minus. What is the name? Try to solve it. I am giving half minute for you. Please solve it. Quick. Try to solve quick. Okay? Let me tell the answer. Here, as it is a negative complex. Just look at here. As it is a negative complex, so metal name will be ended as ATE. Already discussed. Where? Written. Suffix will be ATE. So tetrasano, as is a nickel negative form, nickelate, charge is 2. If you calculate oxidation number, it will be 2. So tetrasano nickelate 2 ion. You can write like this. So this is the complex name. You give another example. Suppose CO MS3 whole 3, then water here, water 2, then 1Cl. Okay, then outside let it be Br2 and water. I can give the nomenclature. You have to see what are the ligands present inside the coordination sphere. It is very important. Then outside coordination sphere, it will be considered as a negative ions. Negative ions means bromine, bromide, sulfate, sulfate, NO3, NO3, that is nitrate, like this. But where it will be written in the bracket, inside bracket, the name will be ATO. That means bromido. If it will be inside, bromido, outside bromide, inside chlorine, chlorido, inside NO3 minus, nitrato, outside nitrate, like this. So you start from this side. So alphabetical aqua, so diaqua, then first amine, it will be first N will come, so triamine first, then diaqua, then chlorido, then cobalt charge is 3 because 1 here, outside 2 and 1 3, so charge is 3, oxidation number 3, cobalt 3, then outside is bromide, no dibromide, only bromide, then as water is present outside as not a ligand, it is just connected to metal ion by hydrogen bond. So it is not a ligand. So bromide monohydrate. Very important, this thing, be carefully, don't be confused. Water outside means hydrate, inside means aqua. You have to use like this. So triamine diaqua chlorido, then cobalt 3 bromide monohydrate. So this is your some examples. I will give you another example, you solve it. This complex. Here you have to see what is the oxidation number of this ion. What is the oxidation number of this ion? Now this is the 0. 2 chlorine means -2. 1 nitrate means -1. That is 3. So cobalt will be 3. So iron will be 3. Then what is the name? The name will be, you start that bracket. That is coordination sphere you start. Coordination sphere is starting from E and C. Chlorido, dichlorido, as it is a diethylene diamine, more than one is used, we can use bis indicate as it is a 2 indicates bis, it is a ethylene diamine, you can use bracket, dichlorido bis ethylene diamine iron, as it is a cation side, it is plus, it is minus. So dichlorido bis ethylene diamine iron charge is 3. Iron 3. Outside NO3 means nitrate. If same NO3 will be inside, it will be nitrato. Outside means simply nitrate. So like this, you practice minimum 100 examples and try to give the nomenclature by yourself, so then you will be more knowledgeable in the nomenclature of complex compound, because sometimes question asking your CBSE examination and also in your competitive examination. So try to practice different examples from different books, then you will be what? You will have better knowledge in the nomenclature of complex compound. Okay? Thank you.